going to discuss the QHEI, which is the habitat evaluation metric that we use in streams in Ohio. The habitat evaluation is typically completed at the same time as your fish sampling, immediately following your fish completion. The Qualitative Habitat Evaluation Index is another multi-metric scoring system. It takes into account the substrate, the cover and habitat, the depth of the stream and velocity, stream development, the riparian, what's around your stream, as well as the gradient and drainage area. Some helpful hints about doing the QHEI. You want to think about what's functional to the aquatic ecosystem. What is there that the fish would be able to use and the macroinvertebrates would be able to use? So when we're talking about substrate, we want to think about a boulder as being functional to fish or non-functional to fish. We'll talk about that a little more later. Look at the entire reach before making any decisions. You don't want to choose your substrate score based on what's directly in front of you. As soon as you get down to the creek, make sure you look at the entire reach. Bring a depth stick with you. You'd be surprised how hard it is to judge depths when you're in waders. So bring a stick with you that is calibrated. Draw your stream reach with enough detail that you would be able to come back and find that site again and tell you where the pools are, where the riffles are, any important habitat features. This is definitely one where practice makes perfect. The more times you do the QHEI, the easier it gets. This is an example of the scoring sheet, which you will see later, but it's divided up into 5 sections. The first section is about substrate. The second is your in-stream cover and habitat. Third is channel morphology, which includes things like sinuosity, stream development, and channelization. The fourth is bank erosion and your riparian. The fifth is your pool, glides, and riffles and runs. And that also includes information about your riffles. And the sixth part, these are things that you would typically calculate in the office either before or after completing a site. This is your gradient and your drainage area. Next, I just want to go through some of these metrics and show pictures that you could see in the field and talk a little bit about what that means when scoring for the QHEI. The substrate one can be difficult. You need to check all of your substrates that are there, but you also need to select your 2 most dominant substrates. When you look at this stream, you see all of these rocks on the top very easily, but what you might not see at first glance is that under all of these rocks is a layer of sand. So when you're choosing your dominant substrates, the big rocks always stand out. You might look at this and say there's a lot of cobble, but actually this is all gravel with a bed of sand underneath it. Embeddedness refers to how much space is there between rocks for things to live and feed. A lot of the fish and macroinvertebrates rely on that space between the rocks, and if all of the space between the rocks is filled in with silt and sand and sediment, there's nowhere for things to live. So functionally, the rocks in this picture here are not worth anything for the fish. Here they can get under the rocks, they can get around the rocks, they could feed in and between the rocks. So this is a very low embeddedness. This is a lot higher embeddedness. Again, when you're looking at your substrate, this one is pretty easy. You look down on here and you see sand. You see sand everywhere. When you're shocking the section for fish, it's a really good idea to pay attention then to the habitat that you're shocking, what you're walking on. This is a really good way to know the things that you'll write on your QHEI sheet later. What you can't see quite so well is the coal. This is all sand with a layer of coal, and there is actually a place on your QHEI sheet to mark the origin of your substrate. And if your entire stream bed was coal, your origin would be from coal. This picture here shows substrate as well as in-stream cover. This one is not a stream that we typically see in southeast Ohio. Lots of big rocks. You've got boulders, you might have some bedrock along the stream bottom. You have undercut banks, root wads, overhanging vegetation, There's a lot of cover, a lot of habitat right here. Another one here. All of this woody debris that's in the water is really great habitat. If all of the woody debris were up above the water, snagged in this tree, it would not be functional cover for the fish and macroinvertebrates. Remember, you're only looking at the functional cover that's submerged in the water. This pile of sticks and leaves, this is definitely in-stream cover. These large trees down in the water provide a lot of cover and shade for large fish. Root mats, this is sort of your nursery in the stream. This is where the macroinvertebrates hang out. This is where you're going to find the crayfish. This is where you'll find lots of small fish. This is a very sheltered environment, usually right along the edge of a creek. This is a good place to find a lot of your smaller species. Overhanging vegetation, this is one you definitely have to look at whether it's functional or not functional. In this photo, this vegetation that's hanging over very close to the level of the stream is providing shade, this is providing cover from aerial predators. This is definitely functional overhanging vegetation. A tree that's 30 feet up and hanging over the creek is not quite as functional as far as a fish right at the surface of the water is concerned. Again, there's a lot of in-stream cover here. You have the woody debris that's actually in the water. You have some aquatic plants providing another nursery area for small fish and macroinvertebrates. Overhanging vegetation. There's a lot of in-stream cover right here at this site. Talk a little more about the functionality. These root wads here that are in the water, they're right on the edge, in a fairly deep pool. This is a very functional root wad. Compare that to this root wad right here that is not even touching the water. There's a couple feet gap between the root wad and the water. This is currently not a functional root wad. If the water level was much higher, it might become functional, but at this stage, this is not a functional root wad. Same goes for boulders. A large boulder in fast-moving water is a very functional piece of habitat. Fish can get behind there and hide from the current. Food would get washed around there where they can sit and food would come right to them. This boulder here that's on a gravel bar is providing no function. So if this is the only boulder in your site, you would not count boulders as a functional habitat. When we talk about development of the stream, this involves your pool, glide, riffle, and run sequence. You want to look at each of these individually. Do you have excellent, good, fair, or poor pools, glides, riffles, and runs? And you can use this chart to categorize each of these as good, fair, excellent, or poor to get a score about your development. If you have a stream that's just one straight run all the way through, no really deep pools, no really shallow riffles, this is definitely not going to get a very high development score. If you have a stream that has very deep pools as well as good rocky, clean riffles, you're going to get a really good development score. Sinuosity, this is how twisty and turny is your stream segment. If you step into the creek and you can see for a mile in each direction, it is very low sinuosity. If you step into the creek and you can't see 15 yards before the creek goes around a bend, it's going to be very high sinuosity. Velocity is really important to the creatures that are living in the stream. Not everything could live in a stream with this fast of velocity. You think the small macroinvertebrates and small darters would probably have a hard time living in a stream with this high of velocity. When you're doing your velocity rating, this is actually a good test. If you can see the water is higher in the front of your boot or the front of your depth stick as it is in the back, this is definitely showing that you have fast and possibly very fast velocity. Canopy cover. Again, this is a functional aspect. This provides shade to the stream. This provides protection from aerial predators. There's a section on the back of the QHEI sheet where you'll actually evaluate the percent open canopy. It's a kind of a confusing metric, so you want to look up and see how much open area is there in your canopy. This varies a lot. Some of our streams are entirely covered with canopy. Some are out in the middle of a stream with no canopy cover. This one here shows another variation in substrate. This is a lot of cobble, some boulders. There's a lot of gravel and sand mixed in here. It also shows your riparian zone. This one you can see a very wooded, shrubby riparian on both sides of the creek, but it looks like it opens up over here where your actual floodplain might be an old field or even a grazed pasture. You always want to look at both sides of your stream when you're evaluating the riparian. A lot of streams will be right at the edge of a hillside. This might be a forested hillside. And again, a grazed pasture, maybe a mowed lawn with just a very thin riparian of one or two trees on the side. Erosion, many streams are eroded pretty badly. A lot of this has to do with your riparian. If your riparian has been removed, if there are crop fields all the way up to the stream, you're going to see extensive erosion. If it's a pretty well undisturbed site, wooded riparian, you usually don't see as much erosion. And this also goes for the right side and the left side of the bank. Make sure you're looking at both sides. Another thing that you have to document is the stability of your riffle. These riffles, there's a lot of large rocks, a lot of gravel, a lot of cobble. Think about a large rainstorm, a lot of water comes rushing through here. Is this riffle going to look the same after all that rain has come through? Probably pretty similar. It would take a lot of force to move these large rocks very far. Whereas if your riffles are just sticks and sand, every time you have an inch of rain, those riffles are going to move and change. That would be a very unstable riffle. This site shows a very wide forested riparian. All the way as far as you can see, there's trees on each side of the stream, compared to the riparian right here in the Hocking River. Zero riparian. There's another section on the QHEI where you can indicate whether the section has been channelized, whether it has been dammed, whether it has been modified. This is definitely one where you would want to mark those sections. Channel morphology. The stream channel is trying to develop some morphology, but it is a channelized section. So definitely very different from this forested stream with a wide forested riparian compared to the Hocking River and its channelized section, mowed all the way to the side of the water, very straight, very low sinuosity. A little more about the QHEI scoring. Each one of those metrics will receive a score. Your metrics are totaled to get a total QHEI score. The higher your QHEI score, the more habitat, the higher quality habitat. The lower your QHEI score, the lower quality habitat. Some stream recovery is actually limited by habitat. You might have a site that the water quality has recovered, the water quality is really, really good, but you still aren't seeing fish there. It could be habitat related. It also goes the other direction. We have some sites that have really great habitat, but the water quality is not yet improved, so you're not seeing the biology return. Habitat scores are extremely variable from one site in one stream to the next site, as well as across the region based on natural geology as well as human disturbances. And that concludes the QHEI portion.